Here begins lesson 14.1, graphing trigonometric functions. I'm going to do this lesson a little bit differently. I'm not going to go at a slower pace, which I've been doing, because I'm realizing, of course, that you can pause and rewind on this. So if I happen to go too fast, I know that you are able to rewind it. So I'm going to kind of step out of my teacher rhythm and do this a little bit faster. Okay? All right. We're going to graph tangent, and we graphed sine and cosine the other day, and now we're going to look at the unit circle again to help us decide what tangent will look like. Tangent of 0, or at 0, tangent is 0. Tangent at 90 is undefined. Actually, I'm going to do this. Undefined. It's also undefined at 270. If we kept on going, it would continue to be undefined every 180 degrees. So now let's plug in our points. Well, at 180 it's 0 again. At 360 it's 0 again. Not much of a graph to look at, but if we look at the 45 degree angles, at 45 tangent, is 1. It's also 1 at between 180 and 270, and here as well. If you go negative pi or over 4 or negative 45 degrees, it's negative 1. And again, here and here. So the graph of tangent is not a straight line, just like cosine and sine weren't. It approaches the dotted line but never crosses it, so it gets infinitely closer but never actually touches it on both sides, and that pattern is repeated. Now the vertical lines are considered asymptotes, which means it can never achieve that value because it would be undefined, but it can get infinitely close. Now looking at this, the period, we go from 90 to 270 is 180 degrees, or pi. And that's different than sine and cosine. Secant. The first thing we want to understand about secant is that it is the reciprocal of cosine. So secant is 1 over cosine. So what we're going to do is we're going to graph cosine because that's familiar to us, plus that has values on the unit circle we can look at. And if you remember, cosine at 0 was 1, and then it was 0 at 90, negative 1 at 80, 0 at 270, and 1 at 360. Now I'm just going to graph this cosine in a dotted manner. If we kept on going, it would follow the same pattern. Okay, now secant is the reciprocal of that. So wherever cosine is 0, the reciprocal would be undefined. And these are the locations where cosine is 0. Now, how do we graph secant then? Well, this boxes it in a little bit for us. When cosine is 1, the reciprocal of it is still 1. So that's going to stay the same. When cosine is negative 1, the reciprocal is still negative 1. So those points they'll have in common. But what happens is we create these parabolas going away from our original sine curve, or in this case cosine. Notice they have asymptotes again. They will not cross, but they will get infinitely close, and a period would refer to where it starts to repeat from beginning to end. So here's 180, here's another 180, So together we have 360. So the period of secant is the same as cosine, 360 or 2 pi. Secant is the reciprocal of sine, or cosecant is 1 over sine. So graphing cosecant, we will follow the same steps, and that is sketch out what sine is. These are just the main points for sine. Sine starts at the origin, and continues on. Same rules here. Wherever sine is 0, then the reciprocal will be undefined. So now we have asymptotes located similar to the other ones, but shifted. And we will follow the same pattern. Wherever sine is -1, so will be cosecant. And wherever sine is +1, so will be cosecant. And we then finish by drawing our parabolas. Going upward when we have a value of 1, going downward when we have a value of -1. And again, the period, 2 pi, or 360. Now we're going to look at these functions. What happens when we graph a sine curve with things that are in it that could cause it to change? In this point we have 3, over here we have 0.5. Now I'll punch up my calculator here and we'll see basically what's going to happen. To see something on the calculator, you have to make sure that your units are properly set up. You have to make sure that your window is properly set up. So here we're going to take y equals, we'll go sine x for the first one, and make sure this is right. I want to make sure my window's right. Now let's go in degrees because that's what we've been working on. So notice that your x min and x max are going to be 360 degrees both directions. That should be enough for us to see. My x scale is going to go by 90 degree increments. So every tick mark represents 90 degrees. Now normally it doesn't get bigger than 1 or smaller than -1. Just so I can see it, I'm going to have y max 5, y min -5. And my y scale is 0.5. I'm actually going to change that. I want my y scale just to be 1, make it simpler to look at. Now if I graph sine, that's what I get. It starts at the origin, goes up, comes back down, and at what would be 360 degrees, it would be right on the money at 0 again. Now if we plug in the next equation, 3 sine of x we have a very similar curve, same x-intercepts, but the peak goes much higher and the valley goes much deeper. And what does that mean? Well, this is a vertical stretch. A vertical stretch, and we will say that this is a vertical stretch by a factor of 3, because if you notice, it was supposed to be at 1, and now it goes as high as 1, 2, 3. Okay, now at this point I'm going to stop. This will be the conclusion of part A, and I'll pick up the rest in part B.